Hello and welcome to the next part of the video tutorials on the Point Cloud Engine plugin for Unity. Starting with the converter, the project contains 4 samples that basically handle different types of conversion. However, before we continue, I will just start with the basic PCD converter to our format. Firstly, if you're exporting from Cloud Compare, you can create your PCD files that way. And in the file you're converting, you should have if you need to rescale, if you don't want a one-to-one conversion of your point cloud, and you want to adjust the scale during the conversion process, you can create a text file called quick drop scale or underscore scale. And with a value of 1, it'll be a one-to-one conversion of scale. 0.5 will be obviously 50%, and 2 would be 2 times the scale. But we'll just leave it at 1. You don't need this file in here, it's just in case you want to modify that. So we will just launch the converter. Some of these point clouds have come from Cloud Compare, so sometimes you need to flip the handedness from left-handed to right-handed, or vice versa. So the first option it gives you is, do you want to flip the coordinates? We will just be converting. Might do the carburetor, so see, yes, I believe I exported that from Cloud Compare. Yeah, I'll recenter on X, Y, and Z axis, and sort of point clouds, carburetor. Actually, I probably should have rescaled it down. I think it's very large. But for now, the converter creates a folder inside the same location as the PCD file. So inside that, you have a text file, which is really just some standard reference. That's what you'll plug into your point cloud scripts in Unity. The .mmf files, the C and the P, is position and color. MFD is the debug visual. So we will cut that and paste that in the Point Cloud Resources version 1 folder. We place it in there because the scripts are hard-coded to this location. It just makes it easier. You'll be able to look at the scripts and modify them yourself if you want to. Also, when you do release a final exe, you will have to create a folder, assets, Point Cloud Resources version 1, and then place your files inside of that. Once added to Unity, you can see them. Carburetor. We will open the basic project and destroy the current point cloud, or destroy the visual for it, and then select the carburetor and connect the loader file. And then once that is connected, we can create the debug visual for it. And yeah, it was a large file, which I wish I had shrunk that down. Well, you can actually shrink it down here if you need to, so 0, 1. And then press play. And this point cloud only has nearly 7 million points. But quite a lot of nice detail. Okay. Now, if we're using the converter, we can merge point clouds. we have a look at the project. The point clouds have persistent data enabled. This allows the converter tool to access the original data so it doesn't discard it. So you've got to remember that that is taking up memory. If we look at the left eye camera, you can see that we don't have to worry about that for this one. We've just got two angels. You could have I can change that to anything, so I actually will do that now. Okay, and now we have two different point clouds. Could be the same point cloud if you wanted to. You can orientate them, position them, etc. And we connect them to the merger file. Now, the only things to be noticed here, we give the export name. This will be the name of the final folder. We need an export path. I've created for each of the converters a folder on the desktop. And we've got two point clouds. One road. If we want to make three, we would type 3, press enter, and add another point cloud in here. But we only need 2 because we've only got 2 there. And press play. Once it's finished, you'll see them visible here. You stop, and it says it's finished. Okay, save that. And now we have our PCD file called the Two Angels inside of our point cloud merged folder. We run the converter version 1.0.1, and because it'll be exported from Unity, we will not flip the coordinates, so we'll say no. I'm not going to worry about recentering. We'll take it as it is, and we'll go to our point cloud merged folder, and you can add quick drop scale here too, or wherever the PCD file you're converting. Okay, select the correct file, that helps. Delete that. And we select our PCD file, not the scale file. As you don't need that there, it's just there in case you want to rescale. We don't need it. So we run it on the point clouds to generate the point clouds. These failed to find match for these. Don't worry about that. That is just currently normals are not supported. Only color and position. In the next release, normals will be possible as well as lighting. Well, that's planned for the next release anyway. So after it's finished converting, we can select it, Control X, copy, and paste in our version 1 folder. And remove that point cloud as soon as it finishes. And Two Angels. And as you see, they're both a single point cloud. And I should really adjust the scale. That is 22 million points combined. Okay. The next converter we'll look at is the static cell. This will give you a better understanding of the next one, which is stream loading. But the static cell, basically what this is there's our original point cloud, and that's a 69 million point cloud. I could duplicate it if I wanted to, but right now we'll just do it on the single point cloud. Down here we have noise reduction enabled, and we also have editor override. This enables a special feature in the plugin, and it'll be version 1. In the .NET 4.6 there's also a version 2, so but we're not using that because we can't use that with 5.6. So of Unity. Here we have our capture width. 1024 is fine for this for now, perfect for virtual reality. You can go higher, but be aware that more it increases the amount of points captured, and however gives better detail. Obviously in the next future release, when we add the .NET 4.6 features, it will allow a better capture and also a small file size, because it will just be referencing the original file, because we have random access and memory mapped files. So, but right now this is what we're working with, and basically have a virtual scanner, which is just an empty object with the script attached to it, and you connect your camera and camera root. Once again, you have an export file paths. We call it static point cell, which will be this folder. Static cell point cloud, and we have 3 cubes, which we also should put their layer to editor layer, and what will happen is we'll do a static cell capture at each of these cube locations, and this, like merging, if you wanted to add more capture cells, you can just add it and duplicate position and add another one. But we only have 3 there, so do it with 3. Don't forget your export name and your export file path, and then select the camera so you can see it and press play. And this takes a little while to load because it's loading in 69 million points. I think it's 69. Yeah, well, basically. It is also capturing with a field of view of 90 to capture all sides. You can modify these scripts if you want to try different things, move more captures, but you're going to get most likely duplicates with this particular method. With the .NET 4.6 version, there isn't duplicates because it's capturing references while it's doing that, so it won't duplicate a reference if it's not seen by the camera. Okay, that's that finished. And that produces, okay, obviously thank you for moving my folders, and that'll produce these files, the 3 PCD files, which are our 3 cells, and we've got a loader file, and this, don't worry about this is about boundaries and stuff you don't need to worry about. So we launch the converter PCD to static cell. Desktop, and just double click the loader, and that will combine the 3 cells into a continuous streamable file, basically. Do you want to delete the original? Yeah, may as well clean up. That'll delete all the things, and then we can cut and paste this into assets version 2. And may as well just and select the version 2 point cloud, and you can just drag that over there. There is no debug visual for the static cells, mainly due to the way their purpose. This last parameter on the script, you can attach the camera controller. There's a reason I have a camera controller, a camera root, and then the main camera, because this is to do with my camera scripts and how they approach virtual reality, and the different controller types. So for me, it was just much easier to do it this way. So best to and also you'll need to keep the naming conventions for the camera. So we've attached our camera controller. That's the part that actually moves, and then the root is attached to this, as you can see here, and the camera is attached to the root. And yeah, it's just to do with avoiding gimbal lock and a few other things. So that's already attached. So when we press play, we see our point cloud with the 1024 capture. As you see, it's not as detailed as the original, however, it's very fast. So as you press G, you can cycle to each of the different cell locations and look around. Streaming is faster in the XE than it is in the editor. You can still fly around though, even though it is a capture. Just teleport. So it's good for teleportation. And you can go higher than 1024. You can 2048 if you want for a capture, but it just depends on current hardware, and you just have to be mindful. The virtual reality still it's very intensive. Like one drop below the threshold, and you are locked at 30 to 40 frames per second. So you really have to find a good balance to your system. Okay. The next one is the Streamloader, which works basically like the point clouds merge, except you don't need to add them to the scene. You just drag the actual files to the elements. So if you say on 3 elements, and basically what this is doing is not merging the point clouds, but turning each point cloud into a static cell. So you could say load a tile of grass or load a tile of pebbles, and be in the same file, and just press G and stream between the 2 different ones, kind of like a cell animation in a way. You can also adjust the resolution. And if I can drag the pebbles, and you just give it a name, we call it Angel Pebble, and an export path to wherever I've put it. Point cloud stream load, and basically just press play on tape. Okay, and nothing shows up there, it's not meant to. Stop it. And basically we just launch the static cell converter again. Go to point cloud stream load and double click. and you would then just cut. I should mention that it also writes the original name of the first point cloud, and then whatever you've written here attached to it. So I probably should have named it different, but we've already got it here, already loaded in. So projects, PC2. Yeah, it's already connected here, so we can see that in action. There's our angel, and we press the G key, it will stream in the pebbles. It's, as I said, it's faster in the standalone exe. In the editor, it's a little bit slower to stream in. And that leaves the final part of the converter, which is the triangle mesh to point cloud. Here we have a hedge with has a whole bunch of parts because it's pretty dense. You don't really have to touch anything. All you have to do is select the converter and drag your mesh into this first parameter. Everything else is fine. You will set your own export path and the name, and don't worry about rescale. That is for an experimental purpose. Just leave it unchecked, and then press play. What this actually is doing is, actually press play and then press space to actually do the conversion. That was very fast, but the reason it was so fast is because if we select camera root, we can see the text size only has 1024, but we want something with more detail, so we would go 4090, actually, yeah, 4096. And we'll go 4096. You can go 8192, that'll produce much more. I think that is the one that produces the 10 million point cloud. But press play, and then press spacebar. What's happening is it is reading the UV coordinates and extracting position, normal, and color from each and it's all done. Yeah, from the mesh. You can see this by looking at the shader for this one. As you see, you got position. It's basically unwrapping to screen coordinates and doing a floating point capture on it. So that mesh is exported to. Okay. To there, and it just came out as a PCD file. And we run the one converter on it. No. And that's done. And we now have a pretty decent point cloud. And if we have a look at that one here, see our hedge, and press play. And there you go. So very simple to use. Everything's set up. You just have to really just press play and read the directions. And yeah, when it comes to exporting your final project, just remember that you will have to create assets and point cloud resource version 1 folder, and the same for version 2. and copy across your actual files, because Unity won't copy them across for you. Okay, so that's basically it. If you have any questions, just ask on the forum. If you're interested in purchasing, please do, and or contact me directly if you want more information. Thanks very much for your time. Bye.